Hey guys, today we're going to learn about independent events with probability. So either you have a dependent event or independent event. For example, if I flip a coin and then roll a number cube, what I get on the number cube has nothing to do with what I get by flipping a coin, right? So those are two independent events. However, if I have a jar of marbles and I want to see what's the probability of pulling out two blue marbles, well, I pull out the first one. Well, depending on what I pull out the first time has something to do with the second reach that I put into the jar, depending on what I pulled out the first time, if it was a blue, if it was a green, and now there's one less marble in the jar. So those would be dependent events. So let me share my screen with you. All right, so today we're going to find out the probability of independent and dependent events. All right, so we've already talked about the number line, the scale. What is probability? We've talked about how a number closer to 0 is less likely to happen, and a number closer to 1 or 100% is more likely to happen. So we've discussed this scale several times now. All right, so Raji and Kara must choose a topic from a list of topics to research for their class. If Raji's choice has no effect on Kara's choice, and vice versa, the events are independent. For independent events, the occurrence of one event has no effect on the probability that a second event will occur. If once Raji chooses a topic, Kara must choose from the remaining topics, then the results or the events are dependent. For dependent events, the occurrence of one event does have an effect on the probability that the second event will occur. So we want to decide if these events are either independent or dependent. Kathy rolls a 4 from a set of cards numbered 1 through 10, and then she rolls a 2 on a number cube. Does what she get on the number cube have anything to do with the cards that she pulled from? It says, since the outcome of drawing a card does not affect the outcome of rolling the cube, the events are independent. Yuki chooses a book from the shelf to read, and then Jeanette chooses a book from the books that remain. So, since Jeanette cannot pick the same book that Yuki picked, and since there are fewer books for Janet to choose from after Yuki chooses, the events are dependent. Joanne flips a coin and gets heads. Then she rolls a 6 on a number cube. Since flipping the coin does not affect the outcome of rolling the number cube, the events are independent. What about this one? Annabelle chooses a blue marble from a set of 3. Each of different colors. And then Luis chooses a second marble from the remaining 2 marbles. So, independent or dependent? Dependent. Since they are picking from the same set of 3 marbles, they cannot pick the same color marble. The events are dependent. So to find the probability that 2 independent events will happen, what we're going to do is we're going to multiply the probabilities of the 2 events. So, for example, I want to know what's the probability of me getting A and then pulling a B or spinning a B. So I'm going to find the probability of the first event. I'm going to find the probability of the second event, and I'm going to multiply those 2 fractions together. For example, I'm going to roll a die. It should be 1 die. What's the probability of rolling back-to-back 6s? So I have 1 die. I'm going to roll a 6. I'm going to pick it up, and then I want another 6. So the first pulling the 6 or rolling a 6 the first time is 1 out of 6, right? And then the second time I roll it, it's also 1 out of 6. So what I'm going to do is I'm going to multiply those 2 probabilities together. So here's all the outcomes. These are all the outcomes of what could happen when I roll a number cube. I could get a 1, and then the second time a 1. I could get a 1 the first time and a 2 the second time. I can get a 1 the first time, then a 3 the second time, so on and so forth. But to roll a 6 the first time, and then a 6 again the second time, I'm going to multiply 1 6 times 1 6, and the probability of me doing that 2 times in a row, getting a 6 2 times in a row, is 1 out of 36. In other words, if I do this experiment 36 times, probability says it'll happen once. All right, what about rolling one number cube 2 times in a row? And I want to get an even number the first time and an even number the second time. So we're going to roll a die. Here's all of the things that can happen. First roll, followed by the second roll. Well, since there's 3 even numbers on a number cube, each time I roll, I have 1/2 of a chance to get an even number. So the first time I roll, it's 1/2 or 3/6. The second time, it's 1/2 or 3/6. Multiply 1/2 plus times 1/2 together, and I get 1/4. What about a compound event? That's what we're doing, 2 things in a row. We're going to flip a coin. What's the probability of flipping back-to-back heads? Well, what's the probability of getting heads the first time? 1/4. No, that's not right. 1/2. And then the second time getting heads, 1/2. So to do that twice, 2 times in a row, I'm going to multiply 1/2 times 1/2, and I'm going to get 1/4. And all that's telling me, the outcomes tells me what could happen. I could get tails the first time and tails the second time. I could get tails the first time and heads the second time. I could get heads the first time and then tails the second time, or finally heads twice would be 1/4. All right, Wyatt has 4 $1 bills in his wallet and 3 $10 bills in his wallet. What's the probability he will reach into his wallet twice and pull out a $10 bill each time? Assume he does replace the first bill. So since he's doing an event, but then he puts the bill back into his wallet, these are still independent events, because no matter what he puts the first time, he's going to put the bill back in his wallet and grab a bill the second time, right? So that makes these still independent. All right, so let's see what happens. We're going to, we want a $10 bill. Well, how many bills are in his wallet? He has 4, 5, 6, 7 bills in his wallet. And how many of them are $10 bills? Well, 3 out of 7. So the first time he pulls out, he has a 3 out of 7 chance. He's going to put that bill back. He's going to do it again, still 3 out of 7. So the probability is 9 out of 49 that he's going to do that. Those events back to back. All right, look at number 2, a bag containing 3 green and 2 purple marbles. A bag contains those marbles. What's the probability of drawing 2 purple marbles in a row from the bag? Now it says if the first marble is not replaced. Well, that makes it dependent events, right? So the first time we have our marbles in the bag, we have 5. And how many of those 5 are purple? 2. All right, now assume we pull out a purple marble, right? So the second time I'm trying to get a purple marble, there's not 2 in there anymore, correct? How many are there in there now? There's only 1, and there were 5 marbles to start with, but I pulled 1 out, so now how many marbles are in there? Now there's 4. That's what dependent events does. It changes your fraction for the second event. So I would have 2 over 20 or 1 out of 10. So probability tells me I would have to do that experiment 10 times to get that to happen once. All right, probability of a compound event. Wait, what does this say? Answers. Oh, let's see if we got them right. So we said 3 out of 7 times 3 out of 7 is 749. which is what is wrong with me? 9/49, that's what we got, yes. All right, and then we said purple than a purple is 2/5, and then 1 times 4, or 1/4, because we took out a purple marble and we have 1 less marble, so 1 out of 10. That's right. All right, Wyatt has, is this the same question? It is the same question. Oh, it's explaining even further to us. All right, what about this one? Find the probability of choosing a green marble at random from a bag containing 5 green and 10 white marbles, and then flipping a coin and getting tails. So if we have, how many marbles do we have? 5 green and 10 white. So we have 15 marbles, and we want to pull out a green marble. So we want to pull out a green marble. There's 5 out of 15. So that's the probability of the first event. And then the second event, flipping a coin and getting tails. So what is the probability of getting tails? 1/2. And then of course I could change that to 1/3. I'm just going to multiply straight across. I get 5/30, and 5/30 is 1 out of 6. 1 out of 6. That's the probability of that happening. Yep, that's what I got. All right, find the probability of choosing a red marble at random from a bag containing 5 red and 5 white, and then flipping a coin and getting heads. Well, there's 10 marbles in the bag. How many of them are red? Well, half of them, right? So we could change that to 1/2. And then to get heads on a coin, we have 1 out of 2 chances. So basically it's 1/2 times 1/2, and we get 1/4. We'd start off with 5/20, and then we would get 1/4. All righty, and that's it. All right, that's it, you guys. So now you have enough information to do the puzzle. What do the police put on a bad pig? Now, all of these problems are all independent, okay? So even on section 3, when it talks about the marble, the bag of marbles, it does say in the directions, you're gonna pick the first marble, then you're gonna replace it, and you're gonna pick the second marble. So don't worry about the denominator changing on these. The second denominator shouldn't change because you're gonna replace the first marble. All right, so all of these on this whole sheet right here are independent events, okay? All right, so when you're done, follow directions, figure out what the punchline of the puzzle is, and send that to me. All right, everybody, have a great day.